Hello and welcome to Maths Plus. We have a really cool maths problem today. We're solving some geometry with some trigonometry and the cosine rule. So let's have a look at this configuration. We have a spire which is vertical is 121 meters, and we need to find this side x which is on the plan. So let's start off by working on the vertical triangles ATC and BTC. So first of all, we're going to look in at the elevation, and if we look at the information which is available with the right angle triangle, we can apply trigonometry with the tan function. So tan theta is equal to the opposite over the adjacent. The opposite, as you can see there, it's TC, so tan of the angle 60 degrees is equal to 121 over the adjacent, which is the one we're looking for, AC. So when we have the ratio like this, we can do a swap. Okay, so the AC can multiply up and the 1060 can divide down. So we can get AC is equal to 121 over 1060 degrees, and we can check that out. So 1060, let's work that out, the calculator, and we will get this square root of 3. So let's place it below, and that's our first value. It's great. Now we need to go on to the other side, which is the near vertical triangle BTC, and we can transfer the information down here onto the plan. So let's look at the other one. So as you can see, it's set up. We have 121, which is the height, which is common with both vertical triangles, and we have the 30 degrees. So again, we have tan of theta is equal to the opposite over the adjacent. Let's substitute in every value. So tan of 30 degrees is equal to the opposite, which is 121, over BC. And exactly like the last problem, we can see we can swap the BC and the tan of 30 degrees. But before we write it together, let's compute tan of 30 degrees, and we will get 1 over the square root of 3. So place it below. At the moment, it looks a bit unfinished, so we can plug this into our calculator and we will get a result of 121 root 3. You can use the fraction button in your calculator, which looks like this. Okay, that's great. So we have two sides. So we can look at the near side, the far side, and we have a plan view now. So as you can see now, we have the AC, we have the BC. So now we're going to look at the plan triangle, and we can solve for x eventually. So if we go to our log tables, we can see we can use the cosine rule. A squared is equal to b squared plus c squared minus 2bc cos a. We have 3 sides and 1 angle. Okay, so let's put it all together. And we can say that the A is opposite the angle. So we'll assign x instead of A. So x squared is equal to, the B now is the 21 root 3. And the C is 121 root 3. So let's substitute everything in and let's work it out. So we can go that x squared is equal to 121 over the square root of 3, all to be squared, plus 121 root 3, again all to be squared, bracketed off like that, minus 2 by 121 over root 3 by 121 root 3 by the cos of the angle in the center, which is 32 degrees. So everything works out on the right hand side to be 23970.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0.78. 0. So we need to get the value of x. So x squared, if we square root x squared, we can get x. So let's work that out. Let's get the square root of both sides. So x is equal to the square root of 23970.78. X is equal to 154.82. And x is approximately 155. So let's take that as our value, 155 meters. And that's the problem solved. So thank you for joining Maths Plus. You are awesome. And keep an eye out for more videos on the way.